Here we have the notes for page 67 and 68. We're still discussing functions, and a function, again, is a rule that assigns to each input exactly one output. We're going to be identifying whether a table, a mapping, a graph, a set of coordinates or points or XY values, however you want to put it, whether they are functions or not. So we're going to see some examples of functions and examples of not functions. So here we can look at all of our x values. As long as none of our x values are duplicated, we know that we have a function. Here we have a 1, 2, 2, 3, and a 3 as our x values or our input values. And as I look at the corresponding y values, if I input a 2, I get out a 3, and if I input a 2 again, I get out a 4. This would not be a function because there is more than one output for the input of 2, and likewise there is more than one output for the value of 3 if I input 3. So this would not be a function. Right here on my mapping, you can see my x values. None of them are duplicated. Each input goes to exactly one output. Here, if I look at my x values or my inputs, I can see that I have more than one output for the value of 2 and more than one output for the value of 3. Therefore, that is not a function. As I look at the graph, I can do my vertical line test, and for every x value, I have only one y value. But if you look at this graph here, I have the vertical line test again. But if I were to do a vertical line on this one, I would have an input of 2 and an output of 3 and an output of 4, an input of 3 and again an output of 6 and an output of 7, which would make it not a function. Here's a couple more representations of different ways that we can identify functions. So we have a set of ordered pairs, points, coordinates, x, y values. We can look at all of the x values. Are any of them duplicated? None of them are, therefore we know that it's a function. In contrast, we can look at all of the x values in this set of ordered pairs, and we have a duplication of a -1. An input of -1 will give me an output of 4, and an input of -1 will give me an output of 6. Therefore, I know it is not a function. Here we have the horizontal table. I'm going to look at all of my x values. None of them are duplicated, therefore I know it is going to be a function. If I look at all of my x values here, I do have the 2 that's duplicated and the 4 that's duplicated. So then we have to look at our output. If I input 2, I get out -5. If I input 2 again, I get out 0. That is not going to be a function. And likewise with the 4, I can't input 4 and get out 5 and input 4 again and get out 10. It just doesn't work. We have another graph here, so I can go through and I can do my vertical line test and draw a vertical line anywhere on the graph, and the vertical line only hits one point, therefore I know that it is a function. Here, if I do a vertical line, I can see that I'm going to hit at more than one point on the graph on that vertical line, therefore it is not a function. Here we have what's called the domain and the range. The domain is x values, so it's just another way of saying x and y. So I can look again at all of my x values or my domain values, and then my range values, which is all my y values, and each x value or domain has exactly one range. If I look at this mapping, however, I have an x value of 1 or a domain of 1 that goes to 0 as well as 15. Therefore, each input or domain has more than one output or one range value. Here's another way that you can do the vertical line test. So if I were to draw a vertical line anywhere on this graph, it would touch that vertical line at only one point. Here, if I draw a vertical line at multiple points, it's going to hit at more than one y value for any given x value. So that's the notes for page 67 and 68. So let's look at the assignment. And again, at the top, I've written up here what a function is. a rule that assigns to each input exactly one output. So our directions on this assignment say to determine whether each relation is a function or not a function. If it's not a function, show why. So explain. Number 1 says explain how to determine if the relation from a set of coordinates is a function or not. So decide for yourself how you are going to write, how you know whether a relation from a set of coordinates is a function or not. I've done this one for you right here. I'm going to look at all of the x values. If any of them are duplicated, I know that it's not going to be a function. None of them are duplicated, therefore I know it's a function. When I look at number 3, I see a 5, a -1, and a 5 again. So the 5 duplicates. It has an output of -12 and an output of -5. It is not going to be a function. Here we have, how do we know whether the relation from a table is a function or not? So we're going to do the same thing. Page 70, here explain how we know that the mapping or the relation map is a function or not. How do we know whether the graph is a function or not? And that's the end of that assignment. When we look at page 71 and 72, we're talking about what's your function. So the following is a list of calls that Marcus made with his cell phone's speed dial. I don't know if everybody is familiar with speed dial, but if you press 5, you're calling your grandpa. If you press 3, you're calling dad. 1, you're calling your girlfriend. 9, you're calling grandma. 8, work. 3 is your best friend. 2 is mom. 1 is girlfriend. 5 is grandpa. 2 is mom. 4 is aunt. 7 is mom. And I started doing a mapping here, so you can take 1 through 9. Again, I like to do it in ascending order. If I dial a 1, I'm calling my girlfriend, or Marcus is calling his girlfriend rather. So 1 goes with girlfriend. So you can see, you can go through and determine what does 2 go to. 2 would go to mom, 3 would go to dad, 4 would go to your aunt. So the rest of the questions on this one just go through information based on the mapping and the table that we see here, and then represent the data in a graph, and then answer the rest of the questions. So that's the assignment there. And then we also have a journal entry that we're going to be doing. So this journal entry is more structured, so be sure to include all the needed information. Please use details and complete sentences when answering questions. Again, we're using our language arts skills of capitalization at the beginning, punctuation, and period at the end. So what is a function? You need to give 2 examples of relation maps that are functions and 2 examples of relation maps that are not functions. How can you tell by looking at a graph whether the relation is a function or not? Give an example of a function and a non-function. Here we're talking about a set of ordered pairs. How do we know that it's a relation, whether the relation is a function or not? And then give an example of ordered pairs that is a function and not a function. And again, we're going to do it with a table. Give examples that are functions and examples that are not functions, and that is the end of the second day of 4.1.